Hello, good day. How you doing? You're welcome back to your online class. I'm Mr. Kitty, your chemistry teacher. Um, so we're going to continue from where we stopped last time. Okay. Last time we looked at acid, base, and salt. We treated salt, the type of salts, and how salts are prepared, both the insoluble and the soluble. Um, Treated the test of salt. Today we'll be looking at two things. Shall we consider two things? And one, we'll be looking at hydrolysis of salt. Then we'll also be looking at water of crystallization. Water of crystallization. These are the two things we'll be looking into or at this afternoon. Okay? So let's start with what we call the hydrolysis of salts. Hydrolysis of salts. Now, good. You know that in our previous class, we treated what we call normal salts. We said that normal salts are salts that are formed where what? All the hydrogen of an acid is completely what? Replaced by what? Equal amount of what? The metallic atom, or by equal amount of the metal, or what? Ammonium what? Ion. Once it has been able to replace the hydrogen ion of an acid, then salt is what? Formed. I will say that a normal salt is formed when it is completely replaced. That is, a normal salt is completely what? Neutral. And we saw that a normal salt we always have what? A pH of 7, and we note which is a point of neutrality in the pH scale, and that normal salt we have no influence on what? Litmus paper. These were some of the things we treated last time. Okay. Now, of course, normal salts can be classified into. We have the following. We have normal salt that is formed from strong acid and strong what? Base. We have normal salts that are formed from strong acid and weak base. We have normal salts that are formed from weak acid and strong base. Okay, these are the three types that we have. Now, when you're talking about strong acid, salt comes from something that stuff like KCl, NaCl, stuff like Na2SO4, let's say K2SO4, and so on. Strong, they are salt forms of strong acid and strong base. Now, this type of salts, when you dissolve they have no what effect on what? Litmus paper, and their solutions are what? Neutral. Okay, so what we are looking at today is hydrolysis of salts, and it has to do with these two. When you have what? Strong acid and weak base, reacting to give you what? Is salt. The normal salt is formed from base, and a normal salt that is formed from what? Weak acid and what? Strong base. Now, the effect of this is that when a salt formed from strong acid in water, that salt, that's the solution of that salt tends to show some what? Acidic what? Property. So the solution will tends to because you know you now see that the solution will be having some what? Acidic characteristics. We turn blue litmus paper red and so on. Meaning the solution becomes what? Acidic. The pH will be less than what? 7. Okay. Now, when a weak acid, a salt that is formed, a normal salt that is formed from weak acid and strong base dissolves in water, it will give you, it's going to give you a solution. The solution of that salt will be a salt. It will be a solution of that will be what? That will be alkalinic in nature. What do I mean by that? You see that when you test the solution with pH, you see that it will show some alkaline character, basic character. It will turn red litmus paper blue. The pH will be above what? 7. Are you getting me? Now, such effects is what we call what? Hydrolysis. Such effect is what we call hydrolysis. So, hydrolysis is a phenomenon whereby salts are dissolved in water to form what? A solution. To form a solution that is either what? Acidic in nature or what? Alkalinic in nature. So it's a phenomenon whereby what? A salt is dissolved in water to form a solution that is either acidic in nature or what? Neutral, alkalinic in nature. Instead of being neutral, but you see it having such acidic characteristics and what? Basic characteristics. So that's what the word hydrolysis is. Please, salt from number 1, strong acid and strong base, does not undergo hydrolysis. It's only for this and this that undergoes what? Hydrolysis. And that's where we are going to concentrate on today. Good. Now, let's take for instance, when we are talking about salt formed from strong acid and a weak base, a very good example is NH4Cl. See, look at it. This chloride, this chloride here is gotten from a strong acid. Why this NH4? Now, at this point, when we dissolve it in water, H4OH plus what? NH4OH plus H2O. Sorry, HCl. Okay? Now, you can see this. This is a base, this an acid. So you can see that when the salt hydrolyzes this, now this is salt. It's a normal salt. This is water. Now in this case, it's hydrolyzed to form ammonium hydroxide and what? Hydrochloric acid. This is strong acid. This is what? A weak base. So meaning the salt was formed for what? A reaction, the initial reaction between what? A strong acid and what? A weak base. So this kind of solution now, this kind of a solution, when you dissolve this kind of salt in water, this is what will be formed. Now, because this is strong acid, because this is strong what? Acid, then it's going to give you, if the solution is going to be what? Acidic in characteristics, in nature, I mean. Now, what will happen is that it will, if you test it with litmus paper, it's going to turn what? Through litmus paper, what? Red. It's going to be acidic in nature. You get that? So that's why what? It's a strong word. That's why we say that what? It's a salt that can be hydrolyzed to form this and this. So this is a very good word example. Okay. Now let us look at another example again. When you have okay, acetic acid. O O plus NaOH aqueous. You can see this now. You can see this. Now this is normal salt. This is water. Here is what? A weak acid. Here is what? A strong base. You can see this now. Now this is an hydrolysis of a salt that result to what? Formation of what? A solution that has a weak acid and a strong base. Now such solution is going to have a basic property. Such solution, if you test it with pH, it's going to be above 7 because of this strong base. This strong base will have influence. It's going to be what? The pH will be above 7, meaning it's the alkalinic in nature. So when you test such solution with litmus paper, it's going to give you what? It's going to be what? A ton litmus paper what? Blue. Okay? That is why before we say that what? The hydrolysis result to formation of what? A solution that is what? Alkalinic in nature because of this strong word base. So we can also have many others like Na2CO3. If you dissolve this in water now, it's going to give you 2NaOH aqueous, liquid, aqueous, and what? H2CO3. You can see when this salt is hydrolyzed now, it's forms sodium hydroxide, which is a strong base and a weak what? Acid. So this kind of solution now, when this salt is dissolved in water, that solution will have what? A basic characteristics to be alkalinic. So it turn red litmus paper blue. If you test with pH, the pH will be what? Above 7. Why? Because of the presence of base. So this is how the effect what takes place. So the phenomenon is what we call what? Hydrolysis. Okay? So whenever you come across this, it's hydrolysis that takes place. Good. So we are through with that. Let's go to water of crystallization. Let's look at what we call what? Water of what? Crystallization. Now, you've heard of some salts that we call they are hydrates. In other words, they contain certain amount of water present in them, like Na2CO3 having 10H2. It's an efflorescent compound. That didn't give us this water crystallization. This salt now contains some water molecules present in the compound associated with this compound. So a compound like this is an hydrate, and such compound have water of what? Crystallization. This water is what we call what? Water of what? Crystallization. Now, when we say water of crystallization, it has to do with the amount of water that what reacts, or let's say the water that reacts with what? A substance through chemical what? During chemical reaction, which lead to formation of what? The salt. Okay. Now, during chemical reaction, now, when the substance is being formed, when it reacts with what? When water reacts with it to form a salt, that substance that is formed, that water that is present in it is what called what? Water crystallization. Okay? Good. Now, such salts that contain water crystallization are what we call what? Hydrates. They are hydrates. Okay? Good. So such salt is what? Hydrate. We see they are hydrous in nature. Now, the one that is anhydrous, that is, anhydrous means that it does not have what? Water crystallization. We have different what we call hydrate. Hydrous and what? And hydrous. When you say it is hydrous, it means it contains water crystallization. If it's an anhydrous, it does not have water crystallization. For instance, now when you have this Na2CO3, this is this what? An hydrous salt. You can see that there's no water crystallization present. But this one is what? A hydrous what? Salt. You can say why? Because it contains this. Okay? But take note, it's not only salts. You know, we call it the word crystals. They are kind of lattice. They are kind of lattice or shape. Let me say, okay, substances are formed. That is, a substance may become what? A crystal. When what? It has what? Water molecule. But it's not everything that are crystals that have what? Water molecule. That's why you see that we say what? That hydrates are crystals, but not what? All crystals are what? Hydrates. It's not all crystals that are what? Hydrates. Like sodium hydroxide pellets now are crystals, but they are not what? Hydrates. Okay? Good. Water crystallization is very important in most compounds, in the sense that it is responsible for the shape of the compounds, and it's also responsible for the color of the compound. That's why when you heat a salt that has some water crystallization, you know, one thing we should have in mind is that this water crystallization does not, let me say, are loosely bound to the salt. So as just simple heating, what happens? The molecular structure of the crystallized structure breaks, collapse, then and the water what? Evaporates off. Okay? So they can easily lose their water of what? Crystallization upon what? Heating. Now, there's definitely a characteristic shape that this salt possesses when it contains water crystallization and color. But immediately they lose their water crystallization, what happens? Their color change, then their water crystal, the shape of the salt will also change. In other words, it becomes it will be distorted, it becomes what? Shapeless. Why? Because an amorphous salt is now what? Formed. So you can see that water crystallization gives what? An hydrate or a crystal salt what? Its shape and what? Its color. Good. So that's what we mean by what? Water of what? Crystallization. The amount of water that a substance reacts with during chemical reaction, or combine with anyway, combine with during chemical reaction to form what? A salt. It's what we call what? Water vapor crystallization. Okay? So today we'll be looking at how we perform some calculations on water or crystallization. How we perform calculations on water of what? Crystallization. But before that, let me give you some other salts that contains what? Water of crystallization. A very good example is copper tetrasulfate 6 pentawatt hydrate. The naming is still the same, just that you end it with the number of molecules of water. Each of one to name the water. Notice copper tetrasulfate 6 salt. But when because it's hydrated, now you call it what? Copper tetrasulfate 6 what? Penta. This is 5 hydrate. Okay, it's a pentahydrate. That pentahydrate means that it contains 5 molecules of what? 5 moles of what? Water. Another good example is iron 2 tetrasulfate 6 heptahydrate. It's an hydrated what? Salt. It contains water crystallization. You can see that the water crystallization there is what? 7. Then we also have others like zinc nitrate. It also contains what? Water of what? Crystallization. This is zinc triazonitrate what? 5 what? Hexa what? Hydrate. So they all contain water of what? Crystallization. Now I want to quickly look into certain calculations on how to calculate water of what? Crystallization. 8.24 gram of blue copper 2 tetrasulfate 6 crystals were heated in a crucible to a constant mass at 110 degrees Celsius. Full stop. The residue that was obtained is 5.31 gram. Calculate the number of molecules of H2O, which is the water that is driven off. Then there you have residue. When you say residue, it means that when it was heated to a constant temperature, what mass was now left? Because when it was heated, some water will leave it. Then a mass will be left. What is the mass? That is what we call what? The residue. The mass is remaining after what? Evaporation. So after heating, what is remaining is what? 5.31 gram. Okay. Then mass of water evaporated. How do you get the mass of water that is evaporated? Is to remove this from this. So mass of H2O evaporated equal to what? 8.24 minus 5.31. And that will give you what? That will give you what now? It will give you 2.93. 2.9 what? That's the mass of that. Now remember that the compound you are looking at is what? Is CuSO4 dot what? SHUO. Is this water you are telling you to what? You are asked to what? To look for. Now, another thing you need here is the molar mass of the anhydrous salt. The anhydrous salt. So, molar mass of CuSO4 will be what? 54 plus 32 plus
that will give you 160 grams per watt. Okay, that will be the what? The molar mass. Now remember the formula, or the formula you are going to apply, since that what?
Mass of residue all over what? Mass of water lost equal to what? Molar mass of an hydrous salt all over what? 18S. This is the formula you can apply. It's very simple. Okay, so the mass of residue is the mass that is gotten after heating. Okay, mass of water loss is when you subtract the residue from this, whatever that you have becomes the mass of water loss. The molar mass of the anhydrous salt. The anhydrous salt is this, only this. CuSO4 there. Okay, that is without the water. That's what I mean by mass of anhydrous salt. Then this 18 is molecule of water, mass of one molecule of water. Then S here is the what? X is what they're asking you to look for. This X. Okay, so this one will give you 18. This S is what you have to look for. So let's substitute the value into the equation and see what we are going to get. Good. So the mass of residue is what? 5.31. Mass of water lost is what? 2.93. Molar mass of anhydrous salt is 160. Then 18, we have what? 18X. Okay. Now, you now have this, cross multiply and do your normal mathematical what? Solving to get your answer. And that will give you 95.38.58 all over 95.58 to be equal to what? 468.8 over what? 95.58. Okay, so you have what? S to be equal to what? 4.90. So it will give you what? 4.9 watts. Tell me that this is approximately what? 5. So with this, you have been able to what? Solve what? The problem. So just apply the formula, fill in your values, you get your what? Your answer. Okay? There are times that the question may not come in that form. What it means here is that this thing contains the molecule of water that it has is what? 5. You can see it. So that's the amount of water that was what? Lost in it. Okay? 5 molecules of water was what? Lost. So you can be told to solve for any problem. So just apply what? The formula and you get your what? Your answer quickly. So that is that. Any problem that you have that you don't understand, you are very free to call me on 08138289827. So we are free to, we can analyze that and get your answer to solve the problem. Okay, so that's what we have for today. So do enjoy yourself and have a nice day. Bye.